All compasses point to a radial toroid geometry. Our harmonic Earth, explained Part 26, the planet's magnetic field, is not a simple bar magnet with two opposing poles. It's a point-to-ring dipole, a toroidal geometry where north plus is concentrated at the center and south is distributed equally around the entire outer circumference. This single insight solves the compass mystery that has confused generations. At the center, the true north, magnetic flux concentrates in a high-density attractor, the positive ground of our planetary circuit. At the perimeter, the so-called south, the polarity spreads across a vast radial ring, functioning as the negative or distributed ground. The field lines emerge from this central north point, arc high into the upper atmosphere along the celestial dome, and return to Earth's surface at the outer radial south. This creates a poloidal flow, a donut-shaped circulation where energy rises at the center, spreads across the sky, and descends at the edges. What happens to a compass needle anywhere on Earth? Because south polarity is distributed equally around the entire circumference, there is no single south point to pull the needle. The magnetic gradient is always strongest toward the center. The needle aligns along the shortest radial line between its position and the central north, with its south-seeking end pointing toward the outer ring perimeter. This explains why compasses work identically in Argentina, Australia, and South Africa. They're not pointing to a magnetic iron core in the center of the Earth. They are aligning with a radial geometry where south is everywhere at the edge and north is one singular point. Gauss's law for magnetism holds. There are no magnetic monopoles. The south is simply spread over a larger area of the circumference, while north concentrates at a single point in the center. This asymmetry explains why north acts as the dominant attractor, even though a complete toroidal circuit exists. The auroras confirm this geometry. Aurora borealis blazes at the center, where magnetic flux concentrates most intensely. Aurora australis, by contrast, appears as a fainter, more diffused ring near the outer circumference, precisely where returning charge disperses across the radial south ground. This radiomagnetic field also provides the invisible tracks for our celestial luminaries. The sun pins itself to the densest toroidal field lines, circling the center in quantum-locked suspension. The ionosphere functions as the conductive medium within this toroid, allowing charge exchange between terminals. And the outer radial south acts as the ultimate electrical ground for the entire atmospheric circuit. The compass does not lie, it simply reveals a geometry more elegant than the textbooks admit. North is a point, south is a circle, and between them flows the living current of our harmonic Earth.